In this presentation, we are going to learn how to calculate the range of a projectile. A bullet is fired horizontally from a story building 15 meters high. If the initial speed is 350 meters per second, determine the maximum horizontal distance covered by the bullet. So before we continue, I want us to interpret this question in diagrams. So we have a story building whose height is given as 15 meters. So this is the building, and then a bullet is fired, and the bullet will trace this path, and then it will hit the ground there. So as the bullet moves, it has two kinds of motions. So we have the vertical motion and the horizontal motion. So the bullet moves vertically through a distance of 15 meters and also horizontally through a distance of, say, x. So we need to take note that the time taken by the bullet to cover the vertical distance should be equal to the time taken by the bullet to cover the horizontal distance. With that background, we can now say, if we consider the vertical motion, in this case, we can say the bullet is under the influence of gravity, and therefore we'll consider the gravitational acceleration as 10 meters per square second. And also, for the vertical motion, when the bullet is still up here, its velocity is 0, that is the initial velocity is 0, and then the height it's supposed to cover is s, which is 15 meters. That is when it moves from the top of the story building to the ground. So from this, we can see that we can apply the equation of linear motion, which states s is equal to ut plus a half gt squared. Just because we have s, we have u, we have g, and for this case, we can determine t. That is the time taken for the vertical motion, and that is obtained as follows. So s we have as 15. Now this term here will be 0 because u is 0. So 0 times t is 0. So we'll only have a half gt squared, and g is 10. So times 10 times t squared. So here we'll have 5t squared is equal to 15, and therefore t squared is 3. From here, t is, so from my calculator, t is 1.7321. So this is the time taken by the bullet to move vertically from this level here. From this level here up to the ground. So finally, it moved from the top up to the bottom, which is still 15 meters, that height. So the time taken to move through this height is 1.7321 seconds. So just like we'd agreed earlier on, the time taken by the bullet to move through the vertical height should be equal to the time taken by the bullet to move through the horizontal length. So for the horizontal motion, remember the question required us to determine the maximum horizontal distance covered by the bullet. So for the horizontal motion, still we are going to use the equation s is equal to ut plus a half gt squared. But take note of this. For the horizontal motion, the initial velocity we were given as 350 meters per second. That is here. And for horizontal motion, this kind of motion is considered not under the influence of gravitational field strength or acceleration. So G is 0. So next, we are also given the time taken, T is equal to 1.7321 seconds. So with this, we can do our substitutions and get S, the horizontal distance. So S is equal to, so for this term G is 0, and therefore this term will become 0. So we have S is equal to UT, and substituting, we will have U is 350 times T, which is 1.7321, and when we multiply, we should get 606.22 meters. And that is the distance covered by the bullet, the horizontal motion. So the horizontal distance x as obtained in this equation, so x is the distance s as we can see in the equation of linear motion. So s is the x we had indicated in this diagram. So the distance is 606.22 meters. And with that, we come to the end of the solution to this problem. I want to thank you for watching. See you in the next one.